Hello, everybody. We're going to do some multiplication with our polynomials now. So we're going to start right off with an example. Let's say I have a 3x squared, and I want to multiply it by a 5x squared y. Now you might recognize that this is the type of problem we did back in the last section, 5.1, or in the first video we had for this unit. It was actually unit 4, chapter 5, some of the text, but that doesn't matter here. We're going to multiply 3 times 5 is a 15. X times x squared is x to the 4th. And this y just kind of hangs there. It doesn't change. So it's a single product, and you can write these factors in any order you want. I'm just going to write it in the most efficient way, which is to keep my x's first, and then my y, and then keep that constant out in front. Okay, that's the coefficient now. So it's not really, I mean, we're not really distributing, we're just kind of condensing our product here into one, all these factors into one product. So it's not really like a distributive property. Now, let's look at another example. This one, if I take let's say I had a 5, and I had an x squared plus x. Well, I am going to distribute now. It's going to be a 5x squared, and then one more multiplication would be 5x. Okay. There's another example. Let's say I have 3x squared times an x squared minus 2x. Well, I just start distributing, but I've got a little more work to do here. I have a 3 times a 1, and I have x squared times x squared, which is x to the 4th. Then I drag that sign down. 3x times 2x is 6. That's 3x squared times the 2x to the 3rd, like that. And then I stop. I can't do anything else because I have unlike terms, and I'm done. So I am distributing. See that? I do distribute when I have monomial times a binomial. Monomial times a trinomial might be like, say, 7xy times x squared y plus 3x y minus 7, for example. Well, I just keep that same thing happening with my distributive property. I'll have a 7 x to the 3rd y squared. It's working with those exponents. And I'll have a 21 x squared y squared. I'm going to add those exponents. 1, 1, and 1, and 1. All that adds up to 2's. And here, no variables, so I just have a 49, but I have an xy. Okay, because the xy is out in front. So 1, 2, 2, and finally 3 multiplications. Okay, 1, 2, 3. And it's finished. That's it. I have all unlike terms, so I can't add anything more. I'm stuck. Okay, now you might say, well, this is going to keep going. The next level would be to take a binomial. Let's say I have an x plus 1 and a 3x minus 5. Binomial times a binomial. Seems like a logical progression. Well, I continue to use that distributive law, which says that whatever's out here in front of this group, whatever's here has to be distributed times both of these. That's what it says. So we could take that literally to mean we'll have to have a 3x times the x plus 1, and we'll have to have a minus 5 times the x plus 1. Okay, well, that means we have a 3x squared plus a 3x and a minus 5x minus 5, which I could then actually simplify because I actually have a couple of like terms here. 3 minus 5. Now, this is a legitimate way to do the problem. And in some cases, it might be beneficial to look at a problem this way. But what I'm going to do from now on is I'm going to do this. I'm going to take the same problem, and I'm going to write it this way. I'm just going to start distributing x times a 3x. That'll give me 3x squared. Then I'm going to do this. Finish it, x times a negative 5. It's minus 5x. Then I'm going to take the 1. That makes a 1 times 3x is 3x. And then I'm going to take 1 times a negative 5, which is a negative 5. Then I'm going to put these together. Okay, so I end up with the same thing. I do 1, 2, 3, 4 in that order. Always working my way left in the first grouping to right, multiplying each of these from left to right. So if I keep that same order, a systematic approach, then I'll never forget to multiply something. So I won't leave out any multiplications. All right, so let's take another example here and just work it through this way. So no gimmicks here, just straightforward distributive property. So we're going to take a 7x squared minus 3x, and I'm going to multiply that by x plus 2, like that. All right, so we start in, and again, you just do your order here. I'm going to take this times this. That's my first product. So that will be this times this, which is a 7x to the third. Then I'm going to take this times that, the 7x squared times the 2. That makes a 14x squared. Okay, so that part's done. Then I'm going to move over to this minus 3 and start working on distributing that. So I'll have to take minus 3 times an x, which makes a minus 3x squared. And then I'll take minus 3x times a 2, which makes a negative 6x, or just a minus 6x, like that. Then I look and say, any like terms? Aha, 2 in the middle. So drag this one down, add these together. That's what? An 11x squared, right? Minus 6x. And that would be my final answer. Okay, that's a 7x cubed plus 11x squared minus 6x. Okay. So let's try one more of those. Let's do another one over here. Let's say I have a 5x minus 3 and a 5x plus 3, let's say. All right, so you start right in. Oops. Okay, I have a 5x times 5x, that's 25x squared. I have 5x times a 3, that's 15x. Then I have a negative 3 times a 5x, that's minus 15x. And then I have a minus 3 times 3, which is a 9. I notice I get lucky here because these two give me a 0. So I don't have to count that 0. I just leave it off, and this would be my answer then. Whoops, I just realized I made a mistake there. Let me fix that. This over here, maybe you realize that should have been a negative, right? Okay, so let's fix that. That's my error. It's going getting a little too speedy there. Okay, so let's fix that and make that. That is a minus 9. Okay, everything else looks okay. So I fixed that mistake there. And that's our answer. Okay, so let's move to the next level. The next level is multiplying. We'll do an example. What happens if you have, let's say we got 2x plus a 1, and you're going to multiply that by maybe x squared minus 3x plus a 3. So a binomial times a trinomial. Well, we just continue our same logic of taking that 2x and distributing it all the way across there. 1, 2, and 3. So one multiplication at a time. We'll have a 2x to the third and a minus 6x squared. That's the next multiplication. And then finally a 6x. Then we move to the 1. And it has to be distributed. 1, 2, 3 places. Now it is just a 1. 1 times anything doesn't change it. It's still going to be an x squared minus 3x plus 3. So now here's something, a technique that may help you in the future. I got to write this someplace. Why not write it underneath the matching terms? This way now when you go to combine like terms, you just kind of have to add in a vertical fashion here. Negative 6 plus a 1 is a negative 5x squared. Okay, so that's plus 1. And positive 6 minus 3, notice these are like terms, makes a 3x. And then plus 3 just kind of hangs in there. And that's finished. So trinomial doesn't bother us. Okay, let's see what happens if we take something a little bit nastier, like say x squared plus x minus 1 times, I don't know, let's say 2x squared minus x minus 1, like that. Okay, so keep the numbers small, but it just means we got to do 3 things times 3 things over here. Each one of these times each one of those. Basically, that's all it means. So everything here, all here, times all here. So everything over here times everything over here. And we'll do it systematically. That way we don't forget anything. So first we have this x squared times 2x squared. I better fix that because now it looks a little sloppy in there. That's a 2x there, so I got rid of that. Okay, so we have a 2x squared times x squared, which is a 2x to the 4th. Then you have x squared times negative x, which is minus x to the 3rd. X squared times negative 1 is a minus x squared. Now you move to the x times all 3 of those. Well, that'll be a 2x to the 3rd, and then x times negative x is minus x squared, and then x times negative 1 is a minus x. Then you got to take this minus 1 times everything here. Well, that just changes all the signs to opposite since it's just a 1. And I'll line that up over here. So it's a minus 2x squared, a plus x, and a plus 1. And then again, I'll use my alignment technique here to combine like terms. So now I have this, which is just an x cubed. This one is minus 4 of those x squareds, and this x, negative x cancel, and this 1 just kind of hangs in here. So that would be my final result then. Okay, so that's about as bad as things are going to get in that section.